Hey, topping your life's math industry, and we're gonna take a look at something a bit interesting. We're gonna learn about how parabolas are more powerful than you think. Well, sometimes they can be overpowered. So when you think of the word parabola, you might think of this. And that is correct. A parabola is a U-shaped line on a graph. And its equation is x squared. Anything with x squared in its equation, and if you ever try to graph it, it will look like something like this. So, parabolas are not a straight line, and they have a curve. That trait is what makes them very, very powerful, because if you enter a field called geometry, or a field called calculus, sometimes you actually get to play with this thing and think logically about it. Going back from algebra, the formula for a parabola was ax squared plus bx plus c. This is the standard formula for finding what the parabola looks like on a graph. But if you try to find a straight line, something that looks like that at a constant rate, then you're gonna have a slope-intercept formula. So if it's a straight line, you probably heard of y equals mx plus b, where m represents the slope, x represents your variable, and your b represents your y-intercept, or your starting position. For the standard one, a is your coefficient, x squared is the equation for the parabola, bx plus c are other figures that we get to use if we want to try and move the parabola to another area. But we're not moving anything anywhere. What we're going to do is think logically. So if it has a curved line and there's a straight line next to it, we can say that parabolas are more powerful, or they're overpowered, because they have more lines that you can even think of. Here's an example. A straight line has an equation, y equals mx plus b. Let's use this marker as a straight line. So let's put it right here. As you move around the parabola, you can have a straight line for every area you put on the parabola. So the more you move the point where the line starts for the slope-intercept equation, the more of them you can find. So we can say that parabolas have an infinite amount of these thingies right over here. We can say that there are infinite number of straight lines in a parabola. Parabola. This is good to know in higher level math. The more you move your point on the parabola, the slope is always going to change. So basically, we can say we have an infinite number of slope-intercept equations. To make a correlation with that, let's say you held a metal bar and you're running across a football field. If you ever try to run in the shape of parabola, but you turn your metal pole, that is actually proving it as well, because you are the one running in this kind of line, and you are also holding the metal bar, and you're also turning it as you go along. Here's an example.
Hey, he's escaping.
And that is why we can think logically that parabolas are actually overpowered in math. Thank you for watching Talented Life's Math Industry. Like and subscribe.